So, let's introduce our next speaker, Engineer Ajit Kulkarni. He is a managing director at MSAK, Messrs AK Kulkarni Consultant Private Limited. He is an electrical engineer graduate with 40 years of experience in various types of projects. Completed over 1100 plus projects including IT offices, data centers, call centers, bank, commercial and many more. He specialized in sustainable, resilient, and energy conscious projects. The experience he has received the Entrepreneurs Award from the Maharashtra Chamber of Commerce and Industry and Agriculture and the Society Interiors Building Design Award. Published numerous technical articles and conducted seminars on technical subjects. He is a member of various technical associations and institutes, and he has 3 patent awaiting approvals. So let's welcome Ms. Engineer Ajit Kulkarni on the dais.
Good afternoon, ladies and gentlemen. Must have a nice lunch to you. And thank you very much, Jain Kulkarni and EFC for calling me for this program. I have got a little time now because of that my lecture has been postponed. Otherwise, I was at a first before the lunch. All right. So what we are going to dive into is the MEP services contribution into the climate mitigation. Every watt that is saved in a building is a watt less to be generated. And the efficiency is the first renewable energy. This is what has been said by Amor Levens. He is a physicist and he is a great enthusiast for the efficiency reduction, efficiency increase. And he has said this. So we have to save each and every watt so that whatever the watt which is generated, which will be get saved. See, MEP is not just the supporting service which can be hid under the false ceiling or certain walls, but basically it is a frontline warrior. And our contribution is invisible for the most occupant, but it is impact for all the visible onto the planets. Now we'll rush through the climate change since we have got a time. That climate change is the means for the shift of global and regional climate pattern and the increasing greenhouse like carbon dioxide, CH2 and nitric oxide which has been increased. We already know about it and must have talked by many of the people over here that it is affecting onto the environment, human, social, food, water scarcity, mitigation, biodiversity, livelihood losses, infrastructure, energy demand. So all this climate change is having impact onto all through this. Now, but that global action has been already initiated and there are already Kyoto Protocol, Paris Agreement and Montreal Protocol. With the Paris Agreement, we are going to reduce down the temperature of the earth. In the global action, another thing is that India is going to have a net zero by 2070. And there are so many other parameters which are going to be taken place into the future. And one of the things which is happening is so many things are important and the renewable energy push is the one thing which we are taking at PM level very much. Also, there are so many policies and commitments has happened. So these are the policies and commitments and net zero is one of the thing what we intend to do by 2070. We are aware of net zero and which we intend to do by 2070. The renewable and energy transition which is going to happen that on 2030 we will be having 500 gigawatt of the energy capacity, the renewable energy capacity, that is the main thing and for which so many activities are going to happen. This also going to happen into next thing. The EV mission which has been already taken, that is 2030, will be having all the EV equipments, EV vehicles which will be coming. So these are some of the actions which will be taking into this climate change. Now, let us jump together toward the emerging technologies of the MEP. When we say MEP, it is electrical, HVAC, plumbing, and firefighting. Firefighting also plays the important and dormant role into that. But HVAC is a more contributing factor because in any building, nearly 40 to 60% of the energy which is being consumed by HVAC, that 40 to 60% comprises of your chiller, AHUs, fans, etc. The next, the guzzler which is there is the lighting industry, that is around 15 to 20%. Then we have got plumbing, that is 10 to 15%, and also we have got lift and then other IT equipments, plug sockets, etc. So these are the main thing which are which we have to focus when we talk about MEP. And main thing which we are intend to talk about is the HVAC. Now, while doing this MEP curtailment of the carbon emission and increasing the efficiency, there are so many factors what we can do, and we cannot go into each and every point over here. But what is happening into the new technologies, that we will definitely see over here. And let's discuss about it. In HVAC, the new things which are going, or the emerging technologies which are going are, those are the radiant cooling, chilled beams, low GWP chillers, VRF, heat recovery, district cooling, and natural ventilation, and AI control. Now let us go into the radiant cooling. What is the radiant cooling? Radiant cooling is nothing but there is a slab is there. Through these chiller pipes which are being laid, these chiller pipes are getting chilled water from the chilling plant which is located onto the building. From there, these chilled water pipelines are going into these chill pipes, and these pipes are traveling into the slab. Because of this, whatever your slab masses which are there, those are getting cooled. As it is, when you want to do the HVAC part, then in that case you have to do the heat load calculation. When we say heat load calculation, it is the peripheral external heat which is coming from the envelope, and also the heat which is getting generated inside. Now consider there is a slab above and slab below, and if this slab is get chilled, then automatically the input chiller which is required to be done will get reduced down. Please note, this sort of a system is already available. It is not theoretical base. Already Infosys has taken care about this. They have done so much plant in Hyderabad and Bangalore for this. This is called as a radiant cooling, and this is an emerging technology, and within some 4 or 5 years this is going to come everywhere. Next will be a chilled beam. What is meant by chilled beam? Now similar to the radiant beaming, what is going to happen is there will be chiller beam like this. You know, there is an active beam and passive beam. It is called as an active beam and passive beam. So it's nothing but a simple structure will be there through which these coils which you can see, the chilled water which is being developed somewhere is getting passed from these chilled water lines, and the heat which is getting generated will be going up and going through the chill pipe, and with which you will get a cool air. This is an emerging technology which is going to happen. Again, Infosys has done such type of installations, and in this there are two types which I said to you. This is a passive chiller and the active beam. So in case of passive, it's a straight hanging thing, whereas in case of chiller beam, this type of coils will be there, through which chill water pipeline will be going into that. Chill water line will be there. Hot water which is going, it will be going inside, and from there the cool air will get. So that what is going to happen is, external chiller which is being placed somewhere else, from there we are bringing the pipeline. Then there is a AHU which is there, and that AHU is cooling us. So that much loss which is there will get reduced down, and there is going to be the definitely efficiency which will increase into that. Let us come to these figures. See, somewhere for the refrigerant chillers which we are using, we are getting now low GWP chiller. Likewise, chilled beam system which is there, where a chiller which is used which is near to the plant, this type of chiller will be placed somewhere else. And with this arrangement, nearly 15 to 20% of the energy can be saved into that, although ROI will be some 5 to 6 years. Now, when we say low GWP refrigerant chiller, GWP means global warming potential. So it means that if CO2 GWP is 1, consider, so for 100 years, suppose CO2 is there. Now, earlier, your R134, which is used, that was having global warming potential of 1430. So 1 carbon is 1 GWP. So for 1430 times which was there. But now what we are getting is a low GWP chiller, and with which we can able to reduce this GWP area. It means that we can get now R432, which has got only 675. To the extent, now future will be there will be R1234 ZE, and in which there will be GWP will be only 10. So it means that we are reducing 16670 to directly 0, or so to the minimum to the 50 GWPs, with which carbon content will get reduced down. These are the new chillers which we can use. This is the emerging technology into the HVAC. So this area has gone. This area you must be knowing R22. This has been phased out. This has been directly from now 134 to the R32. So this is going to be the new thing which will be coming up. Now over here, coming to the point that these are some of the manufacturers who will be doing this. Now this is at nascent stage at Panasonic and Mitsubishi, and few others will be taking over into this. Now next one is that what I wanted to bring to your notice, that what are the benefits. We are going to get nearly 99% GWP from the old HFC. This is one of the most advantageous thing. So there will be energy efficiency there. And apart from that, COP will be there. What is COP? COP means kilowatt, which has been input, which is there from electrical side, and what we are going to get from the outside. So output side, that is a heat coolant what we will be getting. So we will be getting high COP, at the same time low GWP. This is one of the new thing which will be coming up into the future into the market. So this is also emerging technology. Some of the practical things which are there, we get nearly 80 to 90% low impact, as I said, 10 to 20% higher, although it is there, but the life cycle will be good, and therefore you will be having more sustainable solution. That's what we will be getting into this. Lot of people must be knowing about it, and this is being implemented very thoroughly into the VRF and VRV system. Many of the people must be knowing about it. But this system which is used is at very small places, or the small hotels, or the small offices. But now it is going to be getting used widely. So instead of using chillers at one place, again transmitting chilled water line, we might well have VRF system wherein these are the outdoors and these are the various indoors. So you can have the advantage into this is that there are multiple indoor units individually controlling refrigerant flow. It means suppose there are 10 rooms are there, we can have might well small equipment into that, but have one output which is there, one input which is there, that is located somewhere else. So these VRF units will be coming up. Till date, it is being used at very small level into small offices, something like 50,000 on lakh square feet. But this will be used widely now in future, because there is a good efficiency which we are getting into VRF. I'll come to that. Now, another advantage is there, and now people which has been started using into that, because some of the buildings in Pune, if you see nearly 10 lakhs, 12 lakh square feet, they are using the VRF system and promoting the VRF. So you get a better efficiency into this. So with this, you may get an initial cost higher than the traditional ducting and all that thing, but you can get a payback in 3 to 6 years. And by using R32, again you can get a GWP less. This is one of the most advantages. And other advantages is like you get less wastage, personalized comfort. You can control this equipment nicely, properly with the controls, and you can get a comfort out of it. These are the different HVAC system. For your information, I'm just bringing this table. There are DX systems, VRF systems, chillers are there, radiants are there, radiant cooling it means. And then we have got evaporative cooling. Evaporative cooling generally we are not using. It is being used somewhere into the, where the dry climate is there, where the efficiency you can get better. But the important point over here is that the payback is 2 to 3 years, 3 to 5 years, 5 to 7, and 6 to 10 years. But in this case, you can get within 1 to 3 years. But VRF, you can get better payments, payback into this. So this is the one of the more advantages into VRF. Chillers, you get a better efficiency, I mean high efficiency. But in DX system, you have got a moderate efficiency. But in radiant, again, you can get a very high efficiency into this. See, another thing, emerging thing which is coming up is a heat recovery system. Heat recovery in the sense, whatever the heat which we are going to use over here, when it is getting exhausted, it has got a lower temperature. Now suppose this area is cooled at say 23 degrees, and if exhaust is taken at say 24 degrees. So it's not at the envelope temperature or the outside temperature. So whatever the fresh air which is coming in, if that fresh air can be get crossed with that without any mixing, then in that case the fresh air which is coming in can get a cooled air, so that your heat load will be in such a way that AC load will come down. This is the one of the advantage. So I think we should talk about heat recovery whenever we are doing the main design of our building. Number two is that this can be used in hotels, wherein whatever the heat which is going from the condenser coil, we can regenerate for the heaters which are used into the hotels, I mean to the rooms, so that geyser load will come down. So this type of thing which is there, which will be coming in future, this very well. In this, you can get nearly 20% as the saving anywhere. And also you can get an extra installation cost, although it is there, but will get significantly lower down. Now, there is another thing which is coming up, is that the district cooling. Madam has already touched upon this. The district cooling is nothing but, it's a chilled water system which is used for one of the district. We have got a centralized plant, and from there we run a cool chilled water up to the each building where they can utilize the thing. Consider, suppose there are say 10 buildings are there. Now for all the 10 buildings you will require the separate chillers, and then in that case the losses will be there because they are not fully occupied. Suppose building is not fully, so the chiller load will be get reduced down. So your efficiency will get reduced down. So this type of system, if we use it, then in that case, instead of one large plant, in which we would have done that, instead of that we can have a district-wise cooling, and you get an advantage about it. So there is the central chiller plant will be there, there will be distribution network will be there, and insulated underground pipes which will carry chilled water to connect the buildings. So it will look like this. There is a centralized plant, there is a distribution is there, and it is going to various buildings. GIFT City, that's the first district cooling system through this centralized production, and nearly 30% less energy for the traditional AC unit. This has been in function at Gujarat. You get they have deployed this system, and this can be one of the major things which will be happening into the future. Now next, whenever things which are coming daily, we always talk about AI. So AI is now getting embedded in everywhere. Every aspect AI is going up. So similarly, AI is coming up into the HV also. Now, while doing this AI, we'll be having IoT, that is Internet of Things. the equipments which are there. We'll be having machine language equipments, and then platforms will be there. So these some of the HVAC control, there's the Epicons platforms are there. Now with this AI-enabled HVAC control, you can get a real-time monitoring. What is meant by real-time monitoring? That what is happening at this moment is getting onto the dais so that you can get everything, all the patterns across the thing which is there into the building onto the platform. So whatever the inputs which are there, that is being known to the centralized place. It can be a temperature, it can be a HVAC occupancy is there, you can be a CO2 level, humidity level, anything into that. On basis of that, they will be doing the data analysis. After the data analysis is done, there will be pattern recognition. What is meant by pattern recognition? Suppose now we have got this college which is occupant early in the morning, afternoon it is not being used or partly used, and in evening it is hardly used. So knowing this pattern, if at all there is any peak is there, immediately across the AI platform, it will adjust the chiller accordingly or whatever the equipment which is there, and then accordingly with this pattern, they will control the system automatically without any manual intervention. So also there is a predictive maintenance. So what you mean by predictive maintenance is that what is the going to happen into for the chiller or for the AHU or for the filter will be knowing to the AI quite in advance, so that they can suggest to the operator, yes, you can do the maintenance, so that equipment failure get reduced down, and it will be also have the smart building connection. See, if you see this slide in which you can get nearly 15 to 25% again energy, you can get an improved comfort, you can reduce the human error, and the equipment life will get reduced down because you are knowing when to do the maintenance, what is the issue, is there any filter problem is there or something like that, that is to be attended, or fan problem, belt problem, and accordingly they can adjust the thing. Cost comparison, you might get say 10 to 15% more, but definitely ROI will be there by less than 2%, 2 years. Okay, now some of the things, some of the new buildings which have got new things which are coming is a natural ventilation and hybrid cooling. What is meant by that? Instead of making entire the building HVAC, you might well design the building in such a way that where you can definitely make the facade in such a way that you can use partly fans, partly other equipment for ventilation purpose, and partly AC, so that you can reduce down the AC. But this will be working out in conjunction with the architect only, and accordingly huge energy bill can be saved. These buildings are also going to take place. Additional cost will not be there, and there will be long-term saving will be there. In short, HVAC is consuming nearly 40 to 60% of total energy, but by moving smart, efficient, and nature-inspired building, we can count energy used by 30% without sacrificing comfort. So might well, although you are building facade or any occupant industry, be it hospital, might be consuming nearly 40%, but definitely you can target upon right from 10% to 30% so as to reduce down your energy bill, and we can achieve whatever the targets what we are going to get. So this is all about HVAC. Now let's go to the electrical part. When we say electrical, we have got electrical, the current sustainability trend which are there, energy monitoring, we might well do the efficient lighting, smart control, grid management, green UPS, and digital switchgear. Out of all the things, these are some of the things which we will touch upon. Now, what are the current sustainable things? You must have heard the word of smart meter everywhere, okay? But the smart meters which are there presently are not smart meter at all. They are just meters with just antenna with so that you are getting the mapping, etc. But the smart meters which are going to connect with the AI or the IoT sensors will be going to be the next phase, which will be definitely something else, in which there will be IoT sensors will be there, and there will be IBMS platforms will be there. These are a modified platform. The wireless communication has started coming into that, and this information they will get, supplier company will be getting within say 15 minutes, in which they will pass on the voltage, alarms, whatever the faults which are there to the supply company. And over and above, there is going to be the next phase wherein supply company can also issue the things to you. So supply company can send the information such as software, pricing, timing information. So according to the load, they can adjust the timing of your power in such a way that they will save on to the energy generation. At the same time, they will talk to you about the pricing they can do. Because depending in evening time, when there is no load, suppose, then in that case, they can reduce on the price. And you can utilize for certain other aspects. So that is load shading also they can inform you. This is some of the information you can get out of it. You can get alarms also. What is the shutdowns which are going to happen, or if there is a payment is there. So the passage will be from the both the side, which was earlier not there. So these smart meters will be getting a now new machine learning algorithm. So from the historical data, they can predict your consumption, and accordingly they can generate the power so that generation can be optimized and the total GWP can get reduced down and efficiency can get increased. This is something is going to happen. So knowing the consumption profiles and the business type, they can have the energy efficiency into this. Presently, energy monitoring system or the smart metering which are happening, they are this level. But as I said to you, they are going to improve upon into that. And now such type of energy monitoring is going to happen at all the levels, means in all industries and hospital, hotel, this can be deployed. And with these smart meters, you might get a lot of information which was earlier we were not getting, like IBM generate report, alarm targets, efficiency, power effectively, conservation energy, all these things. So in this you can get 5 to 15% and ROI will be 2%. Such type of meters are now getting available and getting used slowly. Now coming to the next is the smart lighting. We have now already entered into the phase of LED. But the LED, when it was started, it was 100 lumens per watt. Now it has gone to 120, 150, 160. So efficacy has started increasing into that. So with this, your energy bill will get reduced down. And with the occupancy sensor, daylight sensor, DMAT, and IoT-based sensor, you might well use smart lighting so that you can get information like that. Now suppose, this is one of the things which are there into the smart lighting. That is a sensor which is there. You can get lighting level control, daylight harvesting which is there, circadian lighting, occupancy level, HVAC management, blinds, parking management, meeting room, asset management, so many other things. What we mean is a circadian lighting, it means that it is as per the sunlight, your lighting will be there, and accordingly the inside lighting will change. The daylight harvesting, you must be aware that as the light is more outside, then in that case so much light is not required. So you can dim light and you can get the energy saving into that. So that sort of a daylight harvesting you can do that. Other things which are additional things which you will be getting into this. And this will save your not only energy but GWP will also reduce down. In this, as I said to you, we might well use the LED lighting, say 150 lumen, and you can select the LED in such a way with the burning hours of 15,000 from 4B. There are various beams are there, and from where you can select the LED, and from that LED you can get a very nice LED out of it, which will give a burning hour of nearly 50,000 hours. So that will be also another thing. So GWP will get reduced down, efficiency will increase. In this you can get nearly 10 to 15% of energy saving, and you can get ROI into 1 to 3 years. In fact, in advanced system, as I said to you, circadian and the daylight, all these things will be there. You will be getting into it. Okay. Now next thing which let me touch upon is your grid management. You must be aware that all we are getting the power from the power station which are quite away, somewhere in Koina, Chandrapur, and from there the power is getting transmitted from the transmission line, and then it is reaching to you through various transformers and substations. So in that there is a big loss which is happening at transmission level. That loss is between say 10%, 15%. So instead of that, now new thing which is coming up, and that thing which is called as a microgrid. So wherever your load which is there, a big load which is there, suppose there is a controllable load which is there, near to that this microgrid will be installed. And this microgrid will be getting supply from locally also, like generator, your solar panel, then your fuel cell power station, the energy storage, and also it is connecting to your grid. So advantage what you are getting over here is that these losses which are happening, that is transmission losses, will get reduced down. This is the new concept which promotion which is happening at government level. You can get a primary function from the microgrid, you can give supply to the various buildings which are there. At the same time, if suppose your secondary function comes into it, in case insufficient power generation which is there, then this microgrid can give supply to the main power station. So this is one of the biggest advantage out of it. With this you can reduce down the losses, improve the customer reliability, and these are the advanced microgrid. There is the generation through the diesel, gas operated generator, wind, solar, etc. which is happening. The battery storage system yet to come in India, but it is under threshold. It will be coming at any time. So this concept is going to happen into the future of microgrid and will be advantageous for us, and we will be getting a more energy out of it. Next point which is touching to it is a smart grid. What is happening into that for achieving into the net zero thing, it's difficult task, but since we have a target and we have to achieve it, how we can do it is that we can do the AI-based forecasting and the platforms, EcoStruxure platforms. These smart grids, TPC grid which is there, is connected by a lot of power stations. So there is one power station, second, third, everywhere. And this grid which is there is going to be get into the smart grid. So presently there is a SCADA system is there, but further to that things are getting shaped, and in which you can control all entire grid in such a way that you are drastically cut the CO2 emission, although payback you can get in 4 to 6 years, and the grid electricity which is there will get reduced down. It means dependency will reduce down, and we will be achieving net zero. This is also emerging trend into the future. We must have heard a lot about this UPS. So now the next thing which is happening into the green UPS. Now in green UPS, there is going to be the efficiency increase. So this efficiency will be say up to 98%. Which was earlier up to the 90 to 93%. So advantage will be there. So with this advantage, you will be getting a better energy saving. You get a smaller footprint, less cooling, and although the cost comparison will be 10 to 30% and ROI into 3 to 5. Those who are in project, they must talk about the efficiency while placing this order with this UPS. We must have heard about these MV switchgears which are there. So they are SF6. Now slowly, this SF6 is getting phased out. And now there is SF6 free switchgears which are coming up. So those SF6 either will be air or fluorocarbon. And they will be with IoT sensors. So with which what we are getting the additional advantage that whatever the switchgear ratings which are happening or whatever the happening at the switchgear level, we'll be getting the information, we'll be getting the predictive maintenance, insulation health also, temperature also, so that the failure rates will get reduced down. So in short, electrical system is every element that is generation, storage, distribution, consumption that can be reinvented for sustainability. The shift is from short-term cheap to the long-term green, where the efficiency, intelligence, and life cycle saving will be the real drive value. Since next is the PHE. When we talk about it, is the smart water meters, leak detection, water efficient fixtures, rainwater harvesting, we are aware of that. Grey water has also started coming up, and smart irrigation system. We are having a lot of problem with this leak which is happening, water loss which is happening. So now the new thing which are coming up is the smart meters which are app-based meters. So all the water which is going to come to us can be monitored onto the app, and with which whatever the water usage happening into the building, which was earlier a manual, will be going on to the app basis so that you can get a correct thing. Not only that, we can get a real-time consumption also, and also the detect system, what is happening, if there is a leak is there, or is there water leakage happening, or the problem issues there, pipeline, etc. All these things will be taken care by this smart water. Now, you may get a 10 to 20% reduction into the water bills, means water consumption. Although the 20 to 30% will be higher cost, but definitely you can get payback in say less than 2 years. Now, we can talk about these water efficient fixtures, that is the waterless, we are aware of that, we are using into this 10 to 15 and 10 to 12 liters minute per taps which is happening. With the low faucets, we can drastically reduce down. We can save some 30 to 50% of water into the washroom. Although the cost is 10 to 15%, but definitely you will get the lifetime benefit out of it. And these faucets are already started using into that. For lead, it is required. Rainwater, I need not say about it. Already people must have used everywhere. You get a good advantage out of this, and you can charge the pit. Definitely you can reuse the water. And not only that, either you can get water to be used, or otherwise you can get your table level up. So with this moderate cost and return which is there for 3 to 5 years. Grey water recycling, wherever the water which is used for these purposes or for the garden, we can recycle it. STP water is which is there, we can clean it, recycle it, we can use for the chiller. So we get an additional benefit out of it, and the water which is required at chiller level can get reduced down. Of course, this is for the smart irrigation system, wherein instead of your conventional type of thing, we might well use a soil moisture sensor. So if soil is moist, all the weather data is properly, we can get it. We can definitely reduce the water content which is there, and with which we can reduce the water wastage, and we can deploy this smart irrigation system. Of course, this is solar water heater and a heat pump. So wherever you are, it is coupled to all your solar consumption which is happening, as well as solar water heater which are there. And that is connected to the heat pump. So according to the requirement, according to the things which are required, you might well get this solar water storage, and with this you can get 60 to 80% energy for the water heating, saves the water heating. cost reduction will be there, although payback will be say within say 2 to 6 years. So this is getting deployed slowly into the hotel industries. Green plumbing, wherever the materials which will be used for the plumbing sizes, we can have, instead of GI, we can have the traditional GI, we can remove, we can have the SDP, PVA or CPVC material, and then we can have the green plumbing material also, and we can reduce down this. So PHE about the rethinking how we use the water from the moment to re-enter the building to the moment it leaves. Smart metering, recycling, efficient fixture and solar heating make sure the drop count. In area where the water scarcity is a real as a climate change, sustainable PHE is no longer optional, it's essential. So now last point which is there, which is fire and safety. This is a new thing possibly for you. Wherever the data center which is there, wherein gas separation system is used. Earlier the gas separation which was used was halon base and having GWP of 7,000. But now the new Novak which has come up, that is having GWP for 1. Now this Novak is 3M has discontinued, so therefore now FK5122 is 12 is being used. So suppose there is a earlier when FM2 was, it was having a ozone depletion level which was no damage, but GWP was 3220. So whatever the leakage which was happening, it was having this effect, but now it will be get reduced down to unity. So this is the advantage out of it. So we have just calculated it, and for this, if we use this new gas, we can get so much teracarbon dioxide emission per year which will get reduced down, and nearly 40,000 cars emission which will be happening, we can reduce down. So this is one of the things definitely we can use for the FM200 point. I have worked out for some earlier and new MEPs practices, but there's a paucity of the time we cannot do this. However, suppose if we do proper calculation, means suppose building size is 10,000 square feet, a lakh square feet, and considering 12 hours per day, and grid emission which is as per 0.702, then in that case, we might well use the calculation this way, that earlier we will be having the kWh total energy that was 29,40,000, which will get reduced down to 20,52,000. So it means that nearly 28,420 years trees we are saving into that, and with which 65,000 will be only needed. So this is the saving what we'll be getting if we do the proper engineering into that. So this is one of the advantages into that. So climate impact can be 46% lower. That may happen. So summary which is there, for far healthier planet, fight the climate change through our efficiency and sustainability, use smart system, sustainable building and collective actions are our front line. Be vigilant onto every watt what we are consuming. Be vigilant onto every drop what we are going to use, and every degree what we are using into that. So that small action will give us a big impact. Thank you very much. I have finished in time. Huh? Thank you. If any question is there.
Any questions?
So everyone is doing energy conservation. It means very good. Thank you very much. Thank you.
Thank you, Ajit sir, for the wonderful presentation. I would like to invite Dr. Kavita Fasate ma'am to felicitate sir. Please, sir. Let's proceed with next presentee, Assistant Professor Director Ninath Oak. He's assistant professor at VJTM, VIT Mumbai. Sorry, VJTI Mumbai. A PhD in Environmental and Water Resources Engineering from IIT Madras and MTech Environmental Science and Engineering from IIT Bombay. His expertise and achievement is published numerous research articles and presented at national and international conferences on environmental engineering. Certified ISO 14001 2015 lead auditor, contributed to project with MOEF and CC, GIZ and UNEP. His research focuses on over 7 years of research experience, aims to develop sustainable waste stream management solution based on resource recovery. His key interests are carbon accounting, environmental impact assessment, circular economy, biomimicry, and sustainable development. Let's welcome Assistant Professor Dr. Ninath Oak.
Good afternoon, everyone. As per the instructions, I would like to be as crisp and as concise as possible. So today's title of my talk is Green Infrastructure and Overall Climate Change Mitigation. So kind of we are looking at the contribution of green infrastructures towards climate change mitigation. This is the presentation outline. I will be going with certain basic details of what is global warming, overall understanding sustainability. We dwell into the topics of green building, certain case studies regarding that, and then we go like what is the pathway to establish certain green infrastructures. Okay. So coming to the introduction, I think we had various excellent speakers before who have really set the stage for my talk. So the effects of climate change are no more a distant future, and it is really crucial how the built environments will be contributing in the overall climate mitigation. From the legislative aspect, in 2008, India formulated the National Action Plan on climate change, and it involves around 12 missions, and it was formulated in line with the United Nations Green Economy Initiative. Okay, the figure which you can see here that particularly outlines the reduction in blue-green spaces in various urban cities in India over the years. Like the data has different years, so for each city there may be different year, but overall there is a reduction in the green infrastructures in urban settings. So we will be looking at what we need is a systematic, documented, and a measured efforts are required to address the overall this challenge of climate change. Now let us look at the basics of global warming. What is this global warming and why it is happening? So little bit of basic physics involved here. So whenever the solar radiations are entering into the Earth's atmosphere, some radiations are absorbed by the atmospheric gases and all, and some radiations are reaching the Earth's surface and they are reflected back from the Earth's surface. What is the role of these greenhouse gases in overall the phenomenon of global warming? I would like to explain that. These greenhouse gases act as a transparent material for radiations which are coming from the sun. That is, the solar radiations can actually pass through the pockets of greenhouse gases present in the Earth's atmosphere. Whenever these radiations are reflecting from the Earth's surface, the reflected radiations have modified wavelengths, they have modified frequencies, and these reflected radiations cannot pass through the greenhouse gases. Eventually, the pockets of greenhouse gases in the atmosphere will reflect them back to the Earth's surface, and this is overall the basic chemistry behind the phenomenon of global warming. So the thing which we are now finding as a major challenge, this was the same phenomenon which was responsible for existence of life on planet Earth. So over the centuries back, the life could exist on Earth only because global warming took place, and eventually the surface temperatures increased and the planet became habitable. In the list of greenhouse gases which is there on the slides, obviously carbon dioxide is the one which is talked about. Methane has very high global warming potential along with these nitrous oxides, There are a set of gases called as F gases. These are chlorofluorocarbons, perchlorocarbons, various multiple gases contributing to these. Okay. Then there is something called as ground level ozone. So ozone, when it is in the stratospheric layer, that is protecting Earth from ultraviolet radiations. But when it is present in the ground level, it acts as a greenhouse gas. Okay. This ozone, the ground level ozone, is mostly generated from the photocatalytic reactions when the sunlight and your vehicular emissions and various volatile organic carbon compounds in the atmosphere, they react. Generally they generate this ground level ozone, and there is one another guy there who is water vapor. So I would like to highlight that water vapor is also one of the greenhouse gas, and this fact further leads to something which is called as a positive climate feedback. So Earth is also a system which is going to react to this overall phenomenon of climate change on its own. There is something called as a positive climate feedback, and there is something called as a negative climate feedback. What is happening is, because of global warming, as the concentrations of greenhouse gases go on increasing in the Earth's atmosphere, the air becomes warmer. Warmer air has higher capacity to accommodate moisture. So warmer air holds more amount of moisture as compared to cooler air. As this warmer air keeps on holding more amount of moisture, that is nothing but water vapor, that further contributes to enhanced greenhouse effects, more global warming. Climate change is effect of global warming, right? Whatever the climate change we are talking about, that is the effect of this overall phenomenon of global warming, and somehow this self-sustaining cycle has initiated already. That is why the climate change impacts are visible seriously across the globe, and this phenomenon of positive climate feedback is further aggravating the impacts associated with our greenhouse gas emissions. So these anthropogenic greenhouse gas emissions are obviously contributing. Along with that, how the nature is reacting to the climate change, there are certain positive climate feedbacks associated here. So we need to address them also. Okay. So to address these challenges, we have come up with something called as sustainability. So let us understand the concept of sustainability in further details. Okay. We call these as the three pillars of sustainability, that is environment, economics and social. So maybe in the earlier era, or particularly in the industrialization era, people were focused on cost profit analysis or cost benefit analysis whenever we are looking at any new business or any new policies. With time, there was a factor of environment which came into the action, and obviously along with that we now look at the societal aspect also. So these are the three basic pillars which are contributing to sustainable development. So here I would like to clearly separate out the concepts of overall environmental engineering and sustainability. So environmental engineering is just one of the pillar of sustainability. Unless you incorporate certain measures to take care of societal aspects and economic aspect, you cannot say that our building or our infrastructure is sustainable. Okay. Further, with recent global developments, now we have moved on to this concept where there are 5 aspects that we are looking at. People is nothing but the societal aspects that is reflecting as people. Economic aspects are being reflected as something which is talking about prosperity. Environmental aspects are reflected as planet, and along with that we are now discussing about the partnerships and global peace. Okay. So whenever we talk about sustainability, I think these are the aspects we should take care of, and without addressing these aspects one cannot say that our infrastructure or our development is sustainable as such. Okay. Eventually, we have arrived at the sustainability development goals. There are 17 sustainability development goals. The target year was 2030, but now the national reports indicate that we need to do much better. We need to direct our efforts vigorously towards this achievement of the Sustainable Development Goals, and we are going to look at how the green infrastructure is going to contribute to this achievement of these goals. Okay, I think everybody is aware about the number of various goals, and we are working towards them. Now let us look at green buildings. So this is the definition of green buildings as such, and this was the most comprehensive definition that I could find. Obviously, by different regulatory bodies and various certification bodies, there are multiple definitions for green building. So green building is the practice of increasing efficiency of buildings and their use of overall energy, water and materials. Okay, reducing the building impacts on human health and environment. So here the human health, we are particularly talking about the indoor environments, occupants of the building. How it is done? Through better siting, better design, construction, operation, maintenance and overall removal. So here we also talk about the end of life of the building. So considering every aspect of the complete building life cycle. So in India, the major certification body is Indian Green Building Council. They look at the certifications for various buildings. So whoever, either the constructed, the actually existing buildings or the newly designed, the new buildings, both of them can apply for such certifications. Along with IGBC, there are GRIHA green building certifications. That is your green rating system for integrated habitat assessments. Okay, these were developed in collaboration with TERI, and these certification systems ensure that any infrastructure that claims themselves as a green building or green infrastructure meets with certain criteria, and only after can call themselves as a green building. So these are the two national bodies that I am discussing, the regulatory bodies. Along with this, there is a LEED green building certification, the leadership in energy and environmental design. This was developed in US. The year was 1998 when LEED was established. Over the years, they have also developed vigorously in their overall assessment of certain projects, whoever are applying for them. So LEED certification, you have either you can be simply a certified LEED building. Along with that, you can be silver certification, gold certification and platinum certification. So there are certain ranges, and as per the building's performances, the criteria are selected. So there are multiple factors which are taken into consideration when we want to talk about green infrastructure. First of all, we talk about the sustainable siting, how you are going to select the site for your project. Obviously, in this, your project should not be out of the scale to the present infrastructure or present urban settings or rural settings, whatever it will be. Your infrastructure should not be out of the scale to the present settings. You always look at the associated transportations, your light pollution aspects, noise pollution, air pollution, all these aspects. And you can see at the bottom, as per the LEED suggestions, so 58% stormwater retained and infiltrated on site. So these are some of the conditions. Only when these are met, you become eligible to be LEED certified. Okay, over and above whatever the performance a building or green infrastructure provides, they are providing for the certifications. Okay, so first is sustainable siting, then obviously energy and atmosphere. So how the indoor atmosphere is modeled, how you are going to look at the ventilations, lighting, temperature control, the comfort of occupants, all these things. Water efficiency, what is being done with the water sources, what is being done with the used water, are you going to recycle anything, are you going for any grey water recycle, all these aspects are assessed whenever we apply for certain these certification. For LEED, I have gone through these details. Obviously, IGBC and GRIHA are based on the similar lines. There also they look at the similar parameters in order to access any infrastructure, building infrastructure. Coming to the materials and resources, we look at what is the percentage of recycled materials used, any potential reuse, what is the nature of material being used, are they renewables, are they exhaustive materials, all these things are taken care. Indoor environmental quality is given separate attention whenever it comes to green buildings. We look at the ventilations, thermal controls, and daylight availabilities in the building and all. And obviously, final point is regarding innovation and processes. So there can be certain site-specific innovations that certain applier has implemented. These innovations are also taken care of when we are accessing any green building. So, for example, in India, regarding use of fly ash in concrete, government has come up with certain regulations that if the industries, like wherever the industry where fly ash is generated, any developments within vicinity of the industry are required to incorporate fly ash in the replace their cement content by certain fly ash. So such local innovations, local advantages what are being done or incorporated in the project as such are analyzed whenever we are analyzing certain green buildings. Okay. This is overall discussion about the integration of blue-green infrastructure. So, by blue-green infrastructure, what I mean is providing certain water bodies within the urban areas and certain green patches. So, here we are actually looking at the blending of built environments, where your greener spaces and your water bodies are well integrated in overall design of your structures. Okay. So obviously, if the integration is not there, you have a water limited spaces. Urban heat island effect can be concerning if there is not well blending of the blue green infrastructures, whereas the urban heat island effect can be well be mitigated when we are integrating these approaches. Okay. So coming to the implementation point, there are various sectors where the integration of blue-green infrastructure can be implemented. Water bodies management, housings, and overall transport. So what is the result of this implementation? Whenever we are blending certain blue-green infrastructure, you can achieve various ecosystem services within your infrastructure. So you don't need to go to distant places, or you need not to be void of such ecosystem services. A well blended blue green infrastructure can provide certain ecosystem services within your premises. You can direct the recycled waters to the green spaces. You can dedicate certain landscapes for these things. You can look for certain carbon storage. I would like to highlight one more point here. Whenever we talk about this carbon sequestration, what I would like to point out is whatever is the amount of carbon currently stored in Earth's atmosphere, nearly 3 times of the amount is stored in Earth's soil. So, troposphere strata is containing thrice the amount of carbon as compared to atmosphere. Eventually, the impacts of climate change, your soil irrigation is aggravated, overall soil surface degradation is aggravated, and certain whatever the carbon content which has been stored in the soil has started releasing back to the atmosphere. So that is kind of a further major concern, and people are really working on that. So that is why we are now discussing about the sustainable agricultural practices, where we try to retain the fertility of the soil, retain the carbon content in the soil, so that carbon sequestration can also be achieved and the carbon content in the troposphere can be retained. Okay. Regarding cost savings, whenever we are integrating these blue-green infrastructures, obviously your surface runoffs can be taken care of within the structures. Wastewater reuse, wastewater recycling, all these opportunities are provided when we are integrating. Only in the urban setting, we need to locate such opportunities separately. Whereas if we are well blending the blue-green infrastructure, various recycling and reuse opportunities are presented. Obviously, the occupant health and overall environmental improvement is achieved through that. This slide presents how the green buildings and SDGs as such can be interrelated. So there are multiple SDGs which can be addressed by development of certain green infrastructures and green buildings. So SDG number 3, 7, 8, 9, multiple SDGs, overall climate action, there will be reduced greenhouse gas emissions from the green buildings. And we are also looking at the partnerships. So through development of such green buildings, we can restore various global partnerships. So I would go ahead with the case studies. In case studies, I have selected one case study from India and another recent case study. I will come to that. That is the international study. So this is Suzlon One Earth building situated in Pune. Anybody had heard about it before? I would just like to. Okay, there are few. So this is the as per LEED, this is platinum rated green building. As per IGB, like it is a 5-star green building as per the Indian standards. And so Suzlon is the manufacturer of renewable energy, wind energy turbines. Whatever the blades are used there, Suzlon is a major global player in manufacturing of wind turbines. Okay. Accordingly, they have developed their headquarters and they call it as a One Earth. The building is named as One Earth, and they have used multiple aspects of green building in designing this. Based on the picture, you can see there is a major water body in center of this building. Okay, so they have utilized this presence of water body in order to maintain the temperature and overall comfort levels across their campus. So this is not a single standalone building. This is the Suzlon campus we are talking about, and in the campus at the center they have provided a major water body. Now what happens whenever we are providing certain water body within an infrastructure? You may be aware that in order to change the temperature, for example, if I want to change temperature of air, I am just giving a rough example, I need to input 10 units of heat. In order to change the temperature of air by 1 degree centigrade, let us say I need 10 units of heat as such. In order to change the temperature of water by 1 degree centigrade, I will need more than 10 units of heat energy, because water has something called as a latent heat. The temperature of water does not change quickly. Somehow this is the whenever we are going to the seas, any coastal area, the wind directions are decided based on the land and sea surface temperatures. At the night time, land will cool faster as compared to sea. Water body maintains its temperature for higher durations. Similar principles are implemented in this Suzlon campus, where they provide this major water body in center. So central water body for temperature stabilization. They look at natural ventilation. So all the sunlight utilization, they go for optimum sunlight utilization. They are using certain glass shields which are protecting the occupants from heat as such, but they are well illuminated. The interiors are well illuminated, but the heat aspects are taken care by using certain glass shields. Okay, the campus goes for grey water recycling. Now I hope the concept of grey water recycling is clear. So grey water is the domestic wastewater except your WC water. Any other type of water, wastewater contributes to grey water. That is your kitchen, food generation, like food cooking, then your cloth washing, bathing, vehicle washing, all these things are contributing to grey water, and the campus goes for grey water recycling. And obviously, as it is a company which is manufacturing wind turbines, there is a sufficient use of renewable energy. They have on campus wind turbines, and there are various central turbine farms, they call it as. From there they take their energy. Okay, the second example that I am quoting, this is one of the airport in Cambodia, and this airport was recently launched on 9th of September. So this is the recent development where they are trying to blend the sustainability aspects and This is a Teco International Airport from Cambodia, and since its launch, now it has been called as the most sustainable building in the world. So from the figure, if you can see at the side, there are certain small squares. These are all the solar panels that are being used. So multiple green building aspects are being used for this airport. Optimum use of natural sunlight. Then vertical gardens are provided, and there are multiple landscaping approaches. Solar energy use, as I said, both the boundaries, they are completely covered by solar panels. They have rainwater harvesting systems. Then there is a natural airflow design to facilitate ventilations. So what happens whenever some structures are designed for this natural airflow, the energy required for ventilations can be reduced drastically. And as I said, when I am saying that this building is being quoted as the most sustainable airport across the globe, obviously there should be certain social aspect also there. So whatever is the natural heritage of the country, the building shapes and building architecture has blended modern sustainability concepts with their natural cultural heritage. Okay, so that is why we are calling it as a sustainable building, and it is blending the environmental, economic and social aspects as such. Okay. So now we will move ahead with something called as a develop strategies that can be used to actually implement green infrastructure facilities. So let us say now after this workshop somebody plans that yes, now our project we want to incorporate these green infrastructure aspects. How to do that? So I have come up with something which is called as a 6M strategy. First, motivation of developers. So multiple stakeholders are involved whenever any urban infrastructure is planned, and motivation from each of the stakeholder in order to drive towards sustainable infrastructure is also required. So client, designer, structural engineer, architect, all these should be well motivated to establish certain green infrastructure. Okay. Obviously, by mind I mean newer technologies you need to implement. So as they say that tomorrow's problems cannot be solved by today's solutions, right? So we need certain interventions, certain proven technologies which can be used, and these will help in establishment of such green infrastructure. Now along with that, you need money, you need certain investments. So in your annual budgets for any firm, annual budget for any company, any manufacturing plant, anything, there should be certain amount of a budget dedicated for the activities related with sustainability aspects, or certain actions that are related with climate change mitigation. Without money one cannot go ahead with actual implementation. Here I am directly talking about actual implementation. I am not talking about the plans or general policy statements. If one need to come up with certain applicable aspects, one needs prior investments. You need to look at the market. So whatever we are developing, so for example, if one says that I want to implement the concept of circular economy, one need to think whatever the products they are going to recover, whether there is an available market for that, whether the current policies are supporting that. Even for water recycling or water reuse, one needs to prior to that analyze what to be done with that recovered water, what to be done with the recycled water. Okay, one of the example I would like to give here, that is the basic example from our Mumbai city. In Chembur, we all know about one fertilizer manufacturer in Chembur, RCF. Okay, you know what RCF is doing at their plant? They have two type of treatment plants. One treatment plant, they have an effluent treatment plant, whatever the pharmaceutical manufacturing effluent, they go with that. Another treatment plant is a basic sewage treatment plant in RCF. What they do is they purchase domestic sewage from municipal corporation, they are treating it, and they are using that treated sewage as a process water for plant manufacturing and other purposes. Now over the years they have excelled to a point that now RCF plants acts as a water positive unit. They are selling their treated water back to the community or wherever the point of use can be, right? So accordingly, if we are planning certain green infrastructure and we don't want to limit only to the basic ventilation and other things, we want to look at resource recovery, we want to look at any potential applications. Along with that, if we are trying to develop certain practice, we need to look at the replicability of that practice also, so that in a given industry we can stand as a, okay, we are the one who are knowing about these practices. If somebody needs, they can approach us. Like this, we need to have certain market. Major aspect, we need to calculate, we need to measure the whatever the mitigations we are planning to achieve. So we looked at the LCA analysis, we looked at overall embodied carbon and all these aspects, right? So whatever the efforts we are doing towards the sustainability, towards climate change mitigation, we should be in a situation to measure those effects based on certain rubrics, based on certain parameters, well defined parameters. It cannot be the case that we will implement something and later we will think, let us plan to analyze what was our contribution to climate change mitigation. That cannot be the case. Prior, we need to select what are the parameters we are going to look at. And finally, actual field scale implementation, and we go for certain mitigation aspects. Here I would like to highlight one more point. In our research, we call it as something which is control or a baseline. So whenever any infrastructure is claiming that given infrastructure is a green infrastructure and we have contributed to reduce carbon emissions, one should know beforehand what was the practice as usual possible emission. Then only I can claim my mitigation. If I don't have such controls, if I don't have any these baseline studies, I cannot or I will not be in a position to claim effectiveness of my infrastructure in mitigating climate change, right? So along with the measurement, it is also important to know about the existing controls, know about the existing baselines. And further, how I would like to state this is, many of you, we have solved these rubric puzzles. There is a rubric and we need to bring each side of same color or individual color, a dedicated color, then only we can say that this rubric is completed. Similarly, these 6 are the phases of certain rubric. If we are missing out on certain one phase, overall establishment of green infrastructure or the intended goals may be missed out somewhere. So we need to look at each and every aspect. We need to look at overall motivations from each and every stakeholder. So this is the actual example from IIT Madras campus, where we did this solid waste segregation exercise, and during a semester we informed people, they started using separate dustbins and very well waste segregation was achieved. Eventually we came to know that at the end all the waste is collected at certain point in the campus and mixed together. Such things may happen, right? So motivation at intra company level, inter company level, all the players should be aware, and we need to address all these aspects. Coming to way forward, I would like to say we need to make certain informed choices in establishing green infrastructures. By repetitive informed choices, we can reach best available practices in that certain sector. So let us say airports we are designing, whatever the best available practices. If we make better choices at individual sector, our airport will be such that that is the best available practice in the field. And eventually we do not need to wait for the regulatory mandates to come, and we can be self-motivated for this, so that whenever the mandates are coming, we should be prepared for that. Regarding sustainability aspects, I would like to clarify. In the year 2018, SEBI came up with the rule that top 10 listed companies on the stock market must publish their annual sustainability report in public domain. Okay, this was the year 2018. In the year 2021, the number was increased from 100 to 1000. That top 1000 listed companies need to publish their annual sustainability reports. So accordingly, if we are doing all the such interventions already, if we are already reaching to the best available practices, I think regulatory mandates will not be having much of the effect on our overall operations, and we will be prepared for them, right? So everyone has a role to play in climate change mitigation at an individual, professional and societal level. So there are multiple developments which have taken place regarding green chemistry, greener material alternatives, greener infrastructure. They all are waiting for the green lifestyles to be adopted. Thank you.
We appreciate the expert talk by Dr. Ninad Oak for sharing their expertise on the topic green infrastructure and climate change mitigation. We will now move into question answer session. We are open to questions now. Audience, if you are having any question, you can ask now. I would like to invite Mrs. Jessita to felicitate Professor Ninad Oak. Thank you, sir. With great respect, I would like to invite Dr. Yogini Deshpande to deliver a speech on the topic Data-Driven Asset Management and Design for Carbon Decarbonization in Infrastructure. Dr. Yogini Deshpande's professional experience includes 20 years in structural design and project management. She has completed over 400 projects. She has an intellectual property on a special purpose board for precast concrete structures. Her academic and library contributions includes she worked as visiting faculty at VJTI Mumbai. She authored books on reinforced concrete, steel structures and statically indeterminate structures. She has published numerous articles and conducted seminars and workshops. She has a board membership, such as she is member of the Board of Studies at KJ Somaya College of Engineering and member of the Board of Examines for ME and BE at Pune University. With great respect, I would like to invite Dr. Yogini Deshpande on the dais.
नमस्कार, गुड इव्हनिंग. बरेच जण झोप काढायला गेले तसं वाटतं मला. आय होप चहा पिऊन येतील परत. सो सगळ्यांना नवरात्रीच्या शुभेच्छा. माझं नाव डॉक्टर योगिनी देशपांडे. Okay, for some reason I started in Marathi. Maybe it's just seeing everyone over here. Unfortunately, so there's some glitch, I think. They read a very wrong CV for me. So now they're telling that they will read mine at the end. I'll just tell you a little brief about myself since the CV was wrong. I'm the technical director for Renuka Consultants, Explorers and Designers Private Limited. I started my career with Atomic Energy Regulatory Board. And I'll come to it in a bit as to why I'm talking about that. And then I went to do my PhD. I did my PhD from Purdue University. I was a faculty at 2 universities in US, and I came back in 2012 because I found the story of India very exciting. My family obviously was continuing to be in Bombay, that's one reason, but I think the story of India, I had a lot of faith, I still do have a lot of faith in the story of India and the Indian infrastructure, development of Indian infrastructure. So I came back in 2012, and since then I have been working with Renuka Consultants, Explorers and Designers Private Limited. We basically function in three verticals, geotechnical services, structural services, and we have a broad-based material assessment center in Taloja, which sort of is the main foundation for the services that we provide. I am going to talk about sustainability, carbon emissions, more from a practical perspective. So I don't have a lot of the data numbers. What I want to talk about is how we are looking at climate change, how we as civil engineers, as professionals, have been working on this concept for quite some time. And there have been some resolutions or some development that definitely has happened. So like I mentioned, I started my career with Atomic Energy Regulatory Board. That was a time when, for the first time in India, we were looking to develop M60, M70 grades of concrete. There was no past precedence for it. There was no past precedence for using fly ash, metakaolin, or silica fume. And a group of 5 people, were the first ones to look at how we can use Indian cements with silica fume, what changes would need to be done in the admixtures that were in those times being sold in India to be used to develop M60, M70 grade of concrete, which today has become fairly a common thing in the industry. There was a huge push for fly ash, and I'm talking about in 1997, 98, 99 time frame. At that point, there was a huge push for use of fly ash. And like earlier, my earlier presenter, Dr. Apte, mentioned, that fly ash, now there is a policy which says that any construction that has about 100 or 200 kilometers around a fly ash this facility has to be, construction has to be using that. Now in 98, it was such that fly ash was available. You could actually just go with a vehicle to any power plant, dump the fly ash and bring it and use it. From there, we Indians, as such, once we find something that is good, sasta, tikau, mazboot is the bottom line for the Indian framework and the mindset. So in 98, there was a huge ton of fly ash that India had. I recently heard that good quality fly ash, so we still have a large amounts of fly ash under the dump but the good quality fly ash has reduced considerably, and we probably have a few years more before the good quality fly ash runs out. So, we can pat on our back that we reused a waste material extensively in various ways, and most probably all of it in construction in itself. So from that perspective, while concrete per se gets a lot of beating as being a product which is not sustainable or creating a lot of carbon emissions, it's also a product which is a very forgiving material in that sense of things. Today, in the complete production of concrete, so I'm talking from the time that cement is manufactured to the concrete is made, in multiple ways, there is a reuse of the recycled materials, from waste being utilized, tires being utilized in the furnace for cement manufacture, and fly ash being used in the development of concrete, and multiple different ways. So when we look at today, so from the days of the late 90s, early 2000 to today, there is talk of sustainability, a talk of climate change, and how we can reduce the impact of it is done in two ways. One is looking at a material from a cradle to cradle or a cradle to grave analysis that is done. And secondly, looking at it from the carbon emissions. What is the amount of carbon emissions that are going to be generated during a particular project or during the usage of it? So this is a monograph that is developed by iStuck team, which is a guide to calculating the embodied carbon. And they have developed, the iStuck team has developed a carbon calculator. They for each aspect. Is the laser pointer working? So, what the calculator looks at is what is the raw material supply in preparation of the manufacturing and the preparation of the material in itself, the product itself. What are the different carbon emissions that are happening for the US as well as the UK, Europe industry. They've also developed actual multipliers that you can say. So, okay, if you're using concrete of 1 cubic meter, then what is the carbon emission for cement? What is the carbon emission in terms of the transport and the manufacturing itself? Then during the construction process, in the transport from a particular, let's say from an RMC facility to the site, then the construction installation process, so vibrators, etc., that could be possibly utilized at site. There are different calculating the embodied carbon methods. Then actually during the usage of the building, what is this? This is where all the griha and the leads and all of the lead aspect comes into picture. Then if it goes into the deconstruction or demolition, the transportation of the demolished material and exit. So this is a general method that they have, iStuck has developed. There, I think Jacobs Engineering has also developed a calculator. Mott MacDonald has developed a calculator similarly on similar lines to calculate what is the embodied carbon for any particular project. Now, the idea is that a structural engineer, when they are developing the specifications, would utilize something like this to ensure that you go towards a net zero aspect of a building construction. Okay. Now the yeah. Take it here. So to ensure that the net carbon footprint is reduced considerably, the different ways that we can do is in terms of intelligent designs, which could be in terms of utilizing higher grades of concrete, proper calculation of loads, and different methods. Make it more data-driven rather than just applying a factor of safety because you don't have much confidence either on the quality or you don't have much confidence on the geotechnical aspect of it. So the factor of safety goes on increasing, each person adding to it, to ensure that there is a lower utilization of materials, and then try and have reduced maintenance cycles. So I'm basically saying that improved maintenance cycles being that there's a reduced maintenance cycle aspect of it. So in general, for the construction industry, these are the ballpark values in terms of what are the global carbon emissions for the construction industry in terms of what is the steel manufacturing, what is the concrete manufacturing, other materials that are adopted. These are the general this. Now, as civil engineers, we have an ability to try and estimate as much as possible, but especially in India, in the construction industry, things come from multiple various different sources, and it's probably very difficult to have a proper data-driven system for all the aspects that are being adopted in the construction site. So we then look at how we can avoid excessive usage of any particular material or any excessive ways that would ensure that there will be higher carbon emissions happening. So try and look at ways to avoid it or reduce it, or else then we go at the other aspect is how we can set off any of the carbon emissions that we can't avoid. So in today's presentation, my focus is primarily to look at some of the case studies where we have worked with clients to see how they can either avoid the carbon emissions or eventually also reduce the carbon emissions in some sense. I'm taking some different case studies to show how we could do it at a slightly micro level or an actual method, because what we've seen the earlier presentations has been more from aspect of how do you account for it, what are the policy methods to do it. So some of the case studies that I'm looking at, one is the usage of monopiles that was adopted for the Mumbai Coastal Road. Second one would be the intelligent reuse of materials for the Navi Mumbai International Airport. We have developed some digital tools. I'm going to show you some of the digital tools that we have developed to ensure that there is a reduced carbon footprint impact. And fourth would be looking at how retrofitting and repurposing of structures, which is going to become an important aspect as we look at the impact of climate change. Some examples from there. So the coastal road is up and running almost to its completion itself. This photograph is, I think, about a year earlier, before the middle bridge was, this particular bridge was completed. Now, in 2019-2020, when the construction of this coastal road started, the design initially submitted during the tendering stage called for utilize design from the ground engineering perspective, called for utilizing a group of piles of 3 to 5 group of piles for each pier. And but as the understanding of carbon emissions, as the push for even for MCGM to have as much possible a net zero structure as possible, the idea to use monopiles got developed, and the contractors also wanted to adopt this particular aspect. Now, in monopiles, basically what it is one pier from top to bottom instead of being a group of piles. What this does is it reduces the construction of the pier cap, which is typically the norm when you have a group of piles. So it also helps in reducing the time taken for construction of the pier caps. So this was the original this was the original option for the this interchanges, where you had a group of piles, so you see this cap coming up, and over here at the top also. Whereas when the monopile option, you had a single pier from the bottom to the top. This is during the construction process in itself. So the larger size diameter drilling adopted did I miss a slide? Okay. So we were involved in this particular project as a sub-vendor for the EPC contractors and specifically for the ground engineering aspect. So we helped them in understanding what would be the ground conditions if monopiles were adopted versus a group of piles being adopted as the foundation. And for this particular, then we developed the specifications, even from the drilling perspective, what the specifications would be, because this was being done for the first time in India. Now, the larger size diameter drilling was adopted for enhanced assessment and ensuring a proper engineering properties for the foundations. We also did multiple different types of pile testing for the monopiles in the latter stage. So the monopile foundations, from a sustainability benefit, I think might be caught on the wrong foot for calling sustainability, because there apparently also has to be a social factor and but there is an economic factor and a environmental factor definitely in this. We looked at the way that it was observed that by the agency that there's going to be 30 to 40% lower embodied carbon than the pile group. So you are having lesser concrete, steel, no pile cap being adopted. Also, you're having to do just one excavation and usage of lesser formwork. So, which eventually would mean that they're using less steel in itself. Typically, one monopile they would be able to finish in about seven days versus 30 days for the construction per pier, which means that there's going to be fewer man and machine movements. Specifically in the sea, it is not very easy to work at sea. What this means is that this reduces the movement of the tug, which takes equipment, which takes the personnel to each time to the barge. If that is getting reduced from 30 days to 7 days, that is a huge reduction in carbon emissions, because the tug is obviously emitting a lot of carbon dioxide. There's a lot of usage of fuel every time the tug goes out in the sea. So these smaller aspects also add on to the construction speed, as well as the reduction in the CO2 emissions. There's also minimal seabed disturbance. I mean, imagine that you're creating and you're drilling just one hole versus drilling 3 to 5 holes within the disk and damaging the water, the seabed around it, damaging the aqua environment that is below. So there's going to be lesser impact on the marine life. Also, quieter construction, one monopile versus 5 group of piles, lower noise, reducing the any aquatic disruption to the fish and the marine life again. Typically, monopiles are always designed as a 100+ year design, so it's easier for maintenance, easier for inspection also. And these typically will always be fully recyclable and reusable at the end of life. So there's a less waste in case the bridge needs to be repurposed or retrofitted. So this was a typical savings that can be observed in a monopile versus a group of piles constructions. Then second example that I'm taking up is of the Mumbai airport. So this is a Google map in the year 2015, and over here there was a large hillock in this portion. As this area was developed for the airport construction, the major this was of what do we do with this hillock portion over here? It needed to be demolished. Now this hillock portion was about 1.2 kilometers in length and about 120 meters in height, which was going to, when demolished, would create about 2.5 crore cubic volume of stone or rock material. So the question was, what do we do with it? The initial this was that they would just ply tractors, trucks, 24/7, and take the material out. But then where do you take that material out? How long? What would be the distance? The cost of that was going to definitely be humongous. So the another option that was adopted by the owners, Adani, was to look at now there was a large portion which was uneven. There was a lot because of the hillock. There was a lot of this. So to bring it at one level, they decided to use this filling, the rock material that would get created by the demolition of the small hillock for filling purposes in itself. But then the next question for Adani was This is something that's never been done in India. We do not have specifications for a there could be rockfill embankments, something like that, smaller volumes for dams, and there are some specifications for it, but not something which is going to take a dynamic load and a continuous dynamic load of jet. And jet fuselage is very heavy. So how do we? What do we do? Do we still opt to having trucks carrying the material out? And we then looked at developing different QA/QC tools to see how the material could still be used at site after the demolition. And we offered them to do a detailed data analysis, testing and analysis by using different techniques. So, so this rockfill embankment from carbon capture, sustainability perspectives was very good. It had a better load-bearing characteristics also, because if we go to fill soil in those regions where filling had to be done for the development of the runway, there was also an aspect of where do we get that much amount of soil, and do we get good quality soil? From where would we get good quality soil? So the option to use the rock obviously was better. It was going to create reduction in the CO2 emissions because of reduced haulage. Otherwise, for 2.5 years, they would keep taking the tractors out. And the best, this was that with rock, you could work in all climatic conditions. So during the rainy season also, the complete embankment filling, preparation of the embankment could go on, unlike if they had opted for the soil embankment filling. So this was the So, 3 different types of rocks were created from the demolished material. Type A, Type A1, and Type B. And Type A was up to 500 mm size, layer thickness of 600 mm maximum. So basically, over here you had rockfill type A1 at the bottom, which was 300 mm down. Then you had rockfill type B, which is 125 mm and down size over here. And each of these layers, you had geotextile. I mean, between these two variations, there was a geotextile that was placed. Now, the quality aspect, or the control over quality aspect, and how can we adopt this particular this of not hauling the material out? Well, the requirement was that quality needs to be maintained in the top layer. How do we ensure that the quality is being maintained? In normal soil conditions, so this is how it was expected to look once the complete construction would have been done. Switching like this. Okay, so from the hillock, this is how, now that it is completed, it would look like. This is a rendering of the airport, but this is where the complete filling has been utilized. But like I mentioned, the major hitch to utilize the filling material and not haul it somewhere away was the quality control aspect. How do we ensure that the filling has been densified properly, and that the density is same everywhere, that there is not much difference in the roller passes that are being done on site. Now, there are certain specifications for rockfill embankments, which look at how the compaction has to be measured and what is the this for it. So in the moth section, if there is it says that if there is a 300 mm or a 500 mm thickness, you have to have minimum of 5 roller passes. But there is no specific reference for testing, and the requirements of compaction are not included in the specifications. There are certain FAA, which are the international standards there. Again, compaction requirements are there, but there is no proper mention of what kind of testing, how many passes. So it's sort of kind of a gray area. And this being an international airport, obviously the quality was a major this for the owners. Now, as in the Navi Mumbai, this also tender also, there was a reference was density, the maximum dry density requirements were included, which was 95% of the this. And testing frequency included for materials and layers, but it was again very vague. So, as quality control, this we suggested to the clients two different ways, which are normally not adopted at site, typically at sites, for testing the QA/QC. One, which is a geophysical method, which is a multi-channel surface wave analysis, which assists in providing information about the uniform density of the filled portion by way of shear wave velocity, or VS. And to understand if there is going to be a settlement, if any settlement for the load application, we conducted zone load tests, which assist in providing information about the settlement versus load. So the multi-channel surface wave analysis geophysical method, in this, in a very basic way to understand, I think most of you must be aware of the ultrasonic pulse velocity that is adopted to measure the quality of concrete, and that tells you an understanding of there is any voids or something like that. Now, this is somewhat similar in that same sense, that there is a wave being created. So there is a transducer and there is a receiver. The only thing in this case is that you have multiple receivers. So basically, you are putting across the complete length. This could be 100 meters, 200 meters, whatever we want to adopt. And we are applying geophones at every 5 meters or 10 meters based on what is it that we want to ascertain from the test in itself. And as in the UPV, there is a transducer which has others to create the wave in itself. But in here, you have to have a hammer and a plate. You create the wave in the earth, and then you have a data logger which picks up the frequencies at different lengths. So this is how the geophones are buried in the soil or the rockfill embankment, and data gets created. So the data that is picked up by the data logger is then analyzed through certain fast Fourier transformation softwares. And what these graphs, pictures are showing us is how dense is the material from top to bottom. So from 1 meter to 20 meters, 1 meter to 1 meter, from 0 meters depth top to bottom, 20 meters below. And this is along the length of it. So you're getting a 2D understanding of what is happening in the embankment below. We can also create such kinds of cuts at different depths. Now, basically what we did then was, we looked at what is the density for the given for different roller parses and how the density is varying versus, so we had one test path, a test patch, where these tests were conducted very regularly and at very lower intervals. And then based on the density, we developed what should be the ideal velocity for proper densification of the embankment. So this was the general that we were seeing, that at 6 to 10 passes, roller passes, depth with at 0.85 to 0.92, we still got a consistent density of about between 240 to 234. So this was that the contractor has to do 6 to 10 passes always for each of those layers. Typically, this is the statistical analysis for various patches that were done, and it was observed that there wasn't much variation. So basically, there was a good quality control, and that quality control was being tested through the multi-channel surface wave analysis test. The zone load test is somewhat like a plate load test. Only thing is that in this case, it is a large size plate. So this is a 5 meter by 5 meter plate, and the load is taken off from these pre-stressed these pre-stressing cables, which are grouted into the ground. And such type of tests were conducted at various locations all along the runway and the airport infrastructure. And then we looked at what was the load settlement curve that was being obtained. So this was one thing, where there is an ability to reduce the carbon emission, but there was some kind of this in terms of, if you're doing something new, will the quality be maintained? And it can be, if we think a little bit out of the box of what tools are available to ensure that the carbon emissions can be reduced. So the other thing that I wanted to mention when I said in the beginning was development of intelligent digital tools. So I have over the years worked for various projects in the ground improvement, geotechnical investigations, slope stability aspects all over the country. And over the years, we have seen that if geotechnical investigations or initial assessments are not done properly for various reasons, there is always a gap in information which leads to higher issues later on. A lot of the slope stability issues that we are seeing in Himachal Pradesh, in Uttarakhand, definitely does come from improper geotechnical assessments. And the aspect of improper geotechnical assessment is not that the intent is not there. Probably the intent is always there, but there are multiple people involved in the data gathering perspective and the assessment perspective of what needs to be done further on. So that what happens is there's a lot of time lost in the data gathering. There is many times we realize afterwards that a particular data has been missing, so you're going back to site to get that particular data. So to reduce this time loss, to improve the construction quality in itself, we at Renuva Consultants have developed some tools for the data gathering as well as data management. So we have developed a geotechnical, this. Okay.
It's getting changed by.
Okay. So this is a software which can be used at site wherever the site may be. It doesn't have to be that it has to be there has to be a proper internet connection, but this software can be used on a tab. And complete information about the site can be input into the software at the site in itself. Now, there are such tools available in the market. Yes and no. We do have tools which have been sold by foreign entities which are license-based. So this, for us, we are not looking at it from a license. We can have multiple users simultaneously. All the information related to the soil, related to the geology, related to the testing that is done at site can be input. Information in terms of what type of equipment was used, what type of what was the water table, what was the type of water that gets flushed out, what is the color of it. All the information can be input right over here. And there is an option of where, the person at site does it, the person in office, the geotech engineer at office checks it, and then release it to the client to see it. Also, this is online and offline. So once, if you are working in the Himalayan geology, where there may be internet internet is not available, once the equipment, the tab comes into a region where internet is available, the data gets immediately synced up with this. Okay. Yeah. Yeah, just skip. Okay, so the reason I'm skipping here, why was this, has from a sustainability perspective or from a carbon emission perspective, a lot of time we saw that is being lost between what the client understands, what the client is able to see right away in real time, and between what we are able to provide, especially if it is not digitized. So this digital tool gives an opportunity for the client to take a look at the data as the work is being done. And typically, geotechnical engineers are the first boots on site. Even the client's engineer doesn't want to come on site because there is no toilet on site. This is, I mean, I have seen this. It's not a joke per se. So what now what happens is there is a proper control of the information. There is an understanding of what can be increased or reduced in terms of the designs that are upcoming. So this tool helps a lot by reducing the time that is lost in getting the information to the client, for the client to take a decision, and for us to go back to site and revisit wherever necessary. It's completely, there's a AI module in it also, so the sample collection, what samples have to be tested or what particular tests should be done, all of that gets done by the software in itself. So a lot of decision-making process is done by the software in itself. This was one site where we utilized this particular software. Was very useful. We were looking at this site more as a forensic purpose. This tunnel, which needed to be opened for public, started showing some sheer failures. And for the past 4 to 5 months, we are looking at gathering data, testing a lot of information around this tunnel to understand what exactly is the reasons for the sheer failures, if not the design, if not the materials in itself. And over here, when we are doing a lot of different types of testing, the decision to take this to say what test has to be done has been much more easier for us by utilizing the software. Okay, again, this is. Okay. Okay. The last point I had said was, in terms of the retrofitting and repurposing of structures. With climate change, there's going to be a lot of risk to the existing structures and the structural resilience of the existing structures. First and foremost is the durability risk, faster degradation of superstructures and the foundations because of change in climate, higher waterlogging, or a reduction in moisture, things like that. Serviceability risk, heat damage to structures, increased deformation over time. Major aspects of geotechnical risk, higher cover depths, landslides, slope failures, foundation settlement, soil liquefaction. Deep foundations could be overstressed because of the loads, damage from clay shrinking or swelling during the moisture movements. Increased demand and extreme event risks are also definitely there. The demand risk is in terms of greater wave, thermal loads, wind loads that happen on the structure, higher hydrostatic pressure, drainage demands, increased stress on the barrages and pre-stressed bridges, accidental loads in terms of more cars, more vehicular traffic, any trains or collisions that might happen around the pier, extreme events such as the floods that we have seen this year, storms and wildfires. And of course, operational risk, increased traffic diversions. Because a particular bridge is not in function, we have to change it to another bridge or another system that creates a risk to the structure that is being used. So all of these aspects is going to have to force us to look at how do we retrofit, what are the systems that we adopt for retrofitting or repurposing every time we look for any structure. And so I'm told that I have very little time. How much? 5 minutes? That's not a lot. So I'll just quickly run through. I think I had made this presentation right here about 2 months back for ICI itself at a conference. But I think retrofit from a climate change and to ensure structural resilience, again, has to be very data-based and a data-driven data-driven exercise, rather than just a very cut-based Band-Aid kind of approach where you say, okay, there is corrosion happening, let me just remove it, put some anti-corrosion, remove the rust from the reinforcement, and do jacketing or carbon fiber or something. So those are straight cut ways to do it, but the methods adopted need to be more data driven to ensure that there is a structural resilience for the upcoming loads or the durability risks that are going to come up. And here I'm going to just quickly run through. We did this a very extensive work for multiple jetties around Mumbai. This was that they wanted to change or improve the crane carrying capacities which are on the jetties. Now, some of these jetties were built, were pretty much sort of heritage level kind of a thing, to the youngest jetty being built in 1917. And so for this purpose, the idea was to ensure that the complete process that it's adopted, which is the asset management, understanding what is the current condition of the asset, what is the operational performance, what are the crane loads that are being utilized currently, what are the rehabilitations that could be possibly done, the recommendation, the cost also from a downtime perspective. So all of these perspectives were looked at, but all of it was done through a very detailed, data-driven process by us. And we adopted a very holistic approach. So we looked at the functionality of the structure and the durability of the structure. So for functionality, we did a very detailed visual observation and mapping, including assessment for the current load by field tests and a lot of detailed lab tests, especially from a corrosion perspective and chloride ingress perspective. Did an analysis through software for future loads. Also did an analysis for the service life, did a service life modeling for the current chloride load that was being observed on those jetties. So eventually, we started off initially with certain scales to describe what is the visual impact, or what are the visual observations. Similar scales were also developed for the observations that were received from the testing in itself. So these are multiple different types of tests. I would like to specifically give more this to the corrosion aspect, because these were exposed to marine environment. The measurement of corrosion of existing was done by multiple different methods, which included EMF, concrete resistivity, and then also looked at a detailed concrete analysis. We did a lot of field tests for the structural assessment in terms of seismic tomography, reinforcement mapping, and impact echo test. So this is a EMF being done, the half cell potential, the concrete resistivity test. We looked at the diffusion, specifically developed the diffusion coefficients, looked at what is the concentration gradient that is being observed currently in the concrete by conducting multiple different types of tests. developed a chloride profile for each of for different locations in the jetty. This is how we did the core sampling and the this. And based on the chloride analysis, the chloride content analysis from the cores that was adopted, we developed a chloride profile. Now, chloride levels correlate with the risk of corrosion. So we correlated that to understand what kind of repair this should be adopted. And looked at what is the remaining life based on these chloride ingress levels in the structure. So we developed detailed service life modeling and statistical modeling based on those, and then developed 2 repair strategies, looking at the cost, downtime, and what would be the enhancement in the structural life of the this. So these are the different ways that we can intervene to reduce the carbon this. It's, not just looking at, so this is the structural development part of it. I'm going to skip because I have very little time. So it's not just, we have to come to the numbers, but how do we come to those numbers? There are different methods or different out-of-the-box solutions would have to be developed. And a consensus system will have to be, where you work with all the partners, the owners, the contractors, and the consultants needs to be adopted. So thank you very much. Any questions?
Thank you, Yogini ma'am, for the wonderful explanation. And I would like to invite Jacinta Sequeira to felicitate Dr. Deshpande. Please, ma'am.